So now the third type of question that is used in that is given in divisibility problems is to find the reminders. So example, so you'll be given a question like this: 7 power 103 when it is divided by 25, you are asked to find the remainder. Find the remainder when 7 power 103 is divided by 25. So the technique here is you have to find the power of 7 which is very close, or which is very close to a multiple of 25. So if you take 25, the multiples of 25 are 25, 50, 75, 100, so on. And the powers of 7 are 7, 49. So if you do into 3, you get 49 into 7, 343, 343, so on. So these are the powers of 7, these are the multiples of the given number. So you have to try to select a number within the powers of 7 which is very close, which is as much close as possible, that is that if the difference is 1, that will be very nice, to a multiple of the given number. So you can see that the 49 here is very close to 50 here. So preferably the difference has to be 1. So if the difference is not equal to 1, you'll have to go for stage 2. So if the difference is 1, you can solve it in one stage. So now what I do is, so I can see that 49 is very close to 50. So now let us try to analyze this. So 7 power 103 can be written as 7 into 7 power 102, that is equal to 7 into 7 square whole power 51, that is equal to 7 times 49 whole power 51, that is equal to 7 times 49 can be written as 50 minus 1 whole power 51, that is equal to 7 times, this is of the form x minus 1 whole power odd number, x minus 1 whole power odd number. So this can be written as 50 times some k minus 1. We have already discussed this in the starting. X minus a whole power n will be of the form kx plus 1 if n is odd, kx minus 1 if n is even, n is odd. Kx plus 1 if n is odd, n is even, kx minus 1 if n is odd. So say 50k minus 1, that is equal to 7 times 50. 50 is a multiple of 25. So 7 times 50 is also a multiple of 25. So this can be written as 25 times some k dash minus 7. So 25 times k dash minus 7. So now if this number, so 7 power 103 is of the form 25 k dash minus 7. So now when this number is divisible by 25, the remainder will be, so here you have minus, so the remainder will be 25 minus 7, which is 18. So 7 power 103 when divided by 25 leaves a remainder of 18. So next, so let us look at this question. In this you are asked to find the remainder when 5 power 5 power 5 power 5 power 5 so on 24 times is divided by 24. So again the logic is very simple. So you have 5 powers here. So if you look at the powers of 5, you have 5, 25, 125, so on. And if you have the multiples of 24, 24, 48, 72, so on. So the question is there a multiple of 24 which is very close to a power of 5? So you can very clearly see that 25 is very close to 24. The difference is 1. So now let us take these two as the reference values. So now let us try to convert this problem into these two numbers. So now in this you can see that 5 power 5 power 5 up to 24 times. So effectively if you take this number 5 power 5 power 5 so on up to 23 times, whatever the number is, you can very clearly see that this number is an odd number, because you are going on multiplying 5 as many number of times, because 5 is odd. 5 power any number will always be an odd number. So that is, you are raising 5 to an odd number of times. So let this be 2m plus 1. We know that every odd number can be written as 2m plus 1. So the given expression, given number is of the form 5 power 2m plus 1. This is of the form 5 power 2m plus 1. So this can be written as 5 times 5 power 2m, and this can be written as 5 times 25 power m. So I am trying to convert my number into 25. That is equal to 5 times 24 plus 1 whole power m. 5 power 24 plus 1 whole power m, that is equal to 5 times. You know that x plus 1 whole power m can always be written as some k times 24 plus 1. So this can be written as 5 into 24 into k. This can be written as 24 some k dash plus 5. So this number effectively is of the form 24k dash plus 5. Hence, if this number is divided by 24, the remainder will be equal to 5. So the answer is 5. So the next type of question that is asked in divisibility problems is to find the last 1, 2 or 3 digits of a very big number. So example, if you have 3 power 400, so 3 power 400, 3 is multiplied by itself 400 times. You can see that it's a very large number. But you are asked to find the last 2 digits of the number. So what's the theory for this type of questions? So the theory is simple. If you have any number, assume that you have a number 1257. So if you want the last 2 digits of any number is nothing but the remainder when the number n is divided by 100. So if the number n is divided by 100, that is 1257 is divided by 100. So 12 times 1200 and the remainder is 57. So when a number is divided by 100, the remainder will be the last 2 digits. When the number is divided by 10, the remainder will be the last 1 digit. When the number is divided by 1000, the remainder will be the last 3 digits. So to find the last 1, 2 or 3 digits is very close to the question of finding the remainder with respect to the powers of 10. 10, 10 square, 10 cube, 10 power 4, so on. So now if you want the last 2 digits of this number, you just need to try to find the remainder when this number is divided by 100. So now again, so 100 is nothing but 10 square. So if you take the powers of 10 and if you take the multiples of 10, 10, 10 into 10, 10 into 3, so on. And if you have the powers of 3s, 3, 9, 27, so on, you can see that this 9 is very, very close to a power of 10. So I'll take my 9 as the base. So 3 power 400 can be written as 9 power 200, that is equal to 10 minus 1 whole power 200, 10 minus 1 whole power 200, that is equal to, if you expand this, because I just don't want the remainder when the number is divided by 10, I want the remainder when the number is divided by 100. So I have to take the last 3 digits. So let us see how this comes. So if you do the binomial expansion, you get 10 power 200 minus C1 times 10 power 199 plus C2 times 10 power 198 minus C3 times 10 power 197, so on. And the last, because the n is even, you get a plus C200 into 1. So that's the last term. And what is the term before this? C199 times 10. And what is the term before this? So this is a negative because the last term is positive. The term before this will be negative. And the term before this will be C198 times 10 square. So on. So this expansion has a total of 201 terms which start with this and which end with this. So can you see that in all these terms you have a lot of powers of 10 and concluding with this. So the numbers, the terms from the first term until this term C198 into 10 square are all divisible by 100 because you have a minimum power of 10 square in all of them. So all these terms can be written as 100 times something minus C199 that is 200. C199 is same as 200 C1. So this is 200 into 10, that is 2000 plus 1. So you can see that this 2000 is also divisible by 100. So I can include this 2000 also in the multiple of 100, that is 100k dash plus 1. So that means 300 3 power 400 is of the form 100 times k dash plus 1. So the remainder is 1, hence the last two digits are nothing but 0, 1. So if a number when divided by 100 leaves remainder 1, the last two digits have to be 0 and 1. So the next type of questions in binomial theorem involves inequalities. So in this type of questions, you have two important results which we need to remember. The first is 1 plus 1 by n whole power n will always lie between 2 and 3. 1 plus 1 by n whole power n will always lie between 2 and 3 for all n greater than or equal to 1. So we know this result in our limits chapter. As n tends to infinity, 1 plus 1 by n whole power n tends to e, that is 2.718 something. So this number, the least number comes when n is equal to 1. So if n is equal to 1, 1 plus 1 whole power 1 is 2, and as you increase this n, the value of this increases, and at n is equal to, at n tends to infinity, that is when n is a very large number, this number tends to the value of e, which is 2.718, so on. So we can see that this number is always in between 2 and 3 for all n greater than or equal to 1. And the second, n factorial will always be in between n by 3 power n and n by 2 power n. N factorial is a multiplication of, is a product of n numbers. So this will always be in between n by 3 power n and n by 2 power n for all n greater than 6. So these are the two important theorems which you need to remember. Now, if you see a question, find the positive integer just greater than 1 plus 0.0001 whole power 10,000. So do you see some relation between this question and the results that we have? So 1 plus 0.0001 can be written as 1 by 10,000 whole power 10,000. So this is of the form, this expression is of the form 1 plus 1 by n whole power n. So we know that this is always in between 2 and 3. So what is the positive integer just greater than this number? So 3 will be the right answer to this question. So in this question, you are asked to compare 100 power 100 and 300 factorial. So now how do we do this? That is, if you have to check whether 100 power 100 is bigger or 300 factorial is bigger. Now let us use our second statement. That is, n factorial is always greater than n by 3 power n and always less than n by 2 power n. Now you can see that, so if I apply this statement for n is equal to 300, so you can see that 300 factorial is always greater than 300 by 3 whole power 300. That is, 300 factorial is always greater than 100 power 300. So 300 factorial is greater than 100 power 300, and you know that 100 power 300 is greater than 100 power 100. It's very obvious. If you multiply 100 by itself 100 times, 100 by itself 300 times, 100 power 300 will be greater than 100 power 100. Hence 300 factorial is greater than 100 power 100. So 300 factorial is a bigger number than 100 power 100. So that's how we compared these two. So now let us compare 300 factorial with root of 300 power 300. So we have to compare 300 factorial with 300 power 300 whole power half, that is 300 power 150. So 300 power 150. So 300 power 150 is same as 3 power 150 into 100 power 150. So 3 power 150 and 100 power 150. So we have already seen that 300 factorial is greater than 100 power 300. So now 3 power 150 into 100 power 150. So root of 300 power 300 is this. So which is equal to 3 power 150 into 100 power 150. This is less than 100 power 150 into 100 power 150. So 3 power 150 into 100 power 150 is less than 100 power 150 into 100 power 150. So this is less than 100 power 300, and 100 power 300 is less than 300 factorial. Hence, root of 300 power 300 is less than 300 factorial.